Welcome to my algebra class. We're on Chapter 8, Section 2. We're working with the coordinate plane, which we're going to be using to plot ordered pairs in our equations that have two variables. Remember, coordinate plane is a plane composed of intersecting lines that form a grid, and we plot ordered pairs on that grid. There are four quadrants or four sections made by the x and y axis. The x-axis is the horizontal line here, and the y-axis is the vertical one. And the quadrants are numbered 1, counterclockwise 1, where both numbers in the ordered pairs in this section are always positive. Quadrant 2, in quadrant 2, the x value here is negative and the y value is positive, so it's negative, positive. In the third quadrant, both the x and the y values in an ordered pair are negative. And in the fourth quadrant, the x value is positive and the y value is negative. The origin is where the two axes cross, and the origin has a coordinate value of 0, 0. When I graph an ordered pair, the x is graphed first and then the y, and the x is how far I go left or right, and the y coordinate is up or down. And there are some formal names for that. The x coordinate is called the abscissa, and the y coordinate is called the ordinate. So if I wanted to graph 4, 5, the 4 tells me to go right 4 places on the number line, 1, 2, 3, 4 on the x-axis, and then 5 up, since they're both positive. And I would plot that point. Negative 3, 2 says go left 3 places from the origin on the x-axis, 3 units, and up 2, and that would be negative 3, 2. If I graph a linear equation, what happens is I come up with a line, because all the ordered pairs in a linear equation will be on a single line that work for the equation. An example, x plus 3 equals y. To graph the line for this equation, all I have to do is find 2 points that solve that equation. And note that all linear equations have a degree of 1. In other words, the highest exponent you see anywhere for the variable is 1. So if I wanted to get I need 2 points to graph the line that contains all the points that satisfy this equation. So if I let x equal 0, then y would have to equal 3. If x was 0, then y would be 3. Another ordered pair, I could let x be 1. And if x was 1, 1 plus 3 equals y, then y would be 4. So if I plot those points, x is 0, y is 3, would be here. X is 1, 1 to the right, 4 up, 1, 2, 3, 4. And then I would connect those points in a line. And if I draw the line perfectly, points on the line would satisfy this equation. For example, this point right here should work. It's 3 x is 3, y is 6. And if I check it, 3 plus 3 equals y, so 6 would equal y, so it works. So this line contains all the points that would satisfy that equation, which are an infinite number of points. The standard form of a linear equation is ax plus by equals c, where a, b, and c are integers. So if I have an equation that is linear in standard form, the highest exponent, first of all, is 1, and it's in the form of ax plus by equals c. So A here is 2, B is -5, those are integers, and 7 is C, which is an integer. So all of these work here. 4 and 9 are integers, 0 is an integer. Here, X is obviously has 0 as for A, plus 1Y equals 3. That's the same as Y equals 3. This example is not in standard form because of the fraction 1/2. I need to have them all integers. This one's not in standard form because the 3x is on this side. If I wanted to make it in standard form, it'd be -3x plus y equals -2. And these are not in standard form because I have x's on both sides and y's on both sides and the -1 on both sides. So they're linear because all exponents are 1, but not in standard form. And then last of all, these are nonlinear equations. If you try graphing them, you would not get lines. This one has an exponent of 2. This one here, if I solved it for y, would be 6 over x, and x would have an exponent of -1 since it's down below. Here, x is, again, in the denominator's place, so its exponent is a -1. And the exponents must be 1 in order to be linear. So these are nonlinear equations. Keeping that in mind, we're ready to solve your problems on page 356, oral exercises 1 to 30, actually it's 1 to 35. So the directions on page 356, we're supposed to refer to the coordinate plane on page 356 to do 1 through 20. And they want you to name the point that is the graph of each ordered pair. So if we go ahead and plot them here, and then you can look at the coordinate plane in the book and find the correct letter. So problem number 2, you have the ordered pair 4, 2. So that would be 4 to the right and 2 up. And if you look at your coordinate plane in the book, that would be letter A. And problem number 4 is 3, -6. So 3 to the right and 6 down. And looking at your book, that would be letter F. That's point F. Number 6, you have 9, -6. So they'd be 9 to the right. And then down 6. And that would be letter Y. Problem number 8 is -9, 0. So looking at your grid, coordinate plane, that'd be 9 to the left. That'd be 3, 6, 9 to the left and stay put. And that would be letter J on the coordinate plane in the book. Problem number 10, you have 11, -5. So plotting that here, that'd be 11 to the right, 2, 4, 6, 8, 10, 11 to the right, and 5 down would be here, and that would be letter Q. And the last one on this coordinate system, number 12, is -3, -10, so that'd be 3 left and 10 down. So if we went up here and did that, 3 left and 10 down, 2, 4, 6, 8, 10. And on the coordinate plane in the book, that would be letter S. Now they want you to give the coordinates in the quadrant of any of each point. So we'll go ahead and take this coordinate plane and copy it. I'm going to move it down and make it a little bit smaller. So problem number 14, you're supposed to locate L and give its coordinates. So if you're looking at your book, L is 9 over and 9 down. So it'd be 9, negative 9. 9 to the right, 9 down. And they want what quadrant it in. It would be in the 4th quadrant. Remember, they go 1, 2, 3, and 4. And 16 is point B, and its B is, find it up in your book. It is in the 3rd quadrant. It's 4 to the left and 2 down. So it's right by here. So 4 to the left would be negative 4, and 2 down would be negative 2. So it's negative 4, negative 2, and it's in the 3rd quadrant. Number 18 is point V, and V is in the 4th quadrant again, and it is 2 to the right and 8 down. So 2 to the right is positive 2, and 8 down is negative 8, and it's in the 4th quadrant. And number 20 is X, and X is on the y-axis 5 up. So it doesn't go left or right, so it's 0, and then positive 5, and it's not in a quadrant, it's on an axis. Problems 21 through 26 are describe the graphs of the following equations. So we're going to graph the equations and then describe them. So x equals negative 1. In order to graph that, we need 2 points. So we'll make our 2 points. X has to be negative 1 for both points to graph it. So if x is negative 1, y can be anything. I could let it be 0. All that it's saying is x has to be negative 1 in our ordered pairs. So I make another negative 1 and choose another value for y. And we could do this till infinity. So if I plotted x is negative 1, 1 to the left, stay put at 0. X is negative 1, down 2. And then connected those points. I get, well, it's a little bit off here. I get a vertical line, up and down line through negative 1, 0. Problem number 24 is y equals negative 3. So this says y has to be negative 3. So I need 2 points to graph this line. This time, y can be any, y has to always be -3, so I'm just going to put -3, -3. And x can be any value. I'm going to use 0 and 1. So if I graph this line, x is 0, y is -3. X is 1, y is -3. And I draw a line connecting those 2 points. This time I get a horizontal line. And it went through 0, -3. 26, y equals 0. 2 points to draw that line. Y always has to be 0, so I put 2 zeros down, and x can be 1, and x could be -1. So drawing that line, x is 1, y is 0. X is -1, y is 0. What I end up getting is the x-axis. So this is actually the x-axis. Y is always 0 on the x-axis. In the next section, 27 through 29, give the coordinates of the points where the graph of each equation crosses the x and y axis. So number 28, I have 5x minus y equals 25. And I want to know where it crosses the x-axis and then the y-axis. If it crosses the x-axis, then the value of y has to be 0. Any place on the x-axis, y is 0. So if I would have to let y equal 0. So I get 5x equals 25. Divide by 5, and x equals 5. So it crosses the x-axis at 5, 0. If it crosses the y-axis, then x is 0. So 5 times, let x be 0, minus y equals 25. So negative y equals 25. So y equals -25. So it crosses the y-axis when x is 0 and y is -25. So the rule is, if you want to know where it crosses the x-axis, let y be 0 and find the value for x. If you want to know where it crosses the y-axis, let x be 0 and then find the value for y. And the last set of problems, classify each equation as linear, in standard, linear equation not in standard, or nonlinear equation. So number 30, I have 2x plus 5y equals 2. And I'm checking to see if it's in the form of ax plus by equals c, where a, b, and c are integers. Well, this works. And the value, the exponents for the variables has to be 1. Well, this is x to the first and y to the first, and 2, 5, and 2 are integers, so this is linear standard form. Number 32, x over 4 plus y over 4 equals 1. Well, the exponent for x and y is 1, so it is linear. But it's not in standard form because this is actually 1/4 x plus 1/4 y equals 1. And 1/4 is not an integer. So it's linear, but not in standard form. (34) that was a 7. 34, we have x plus y equals x minus y. And remember, standard form is ax plus by equals c. This is obviously not in standard form, but it is linear because the exponents are all ones. It's all ones here. So linear, not in standard form. That concludes the evens. There are no answer keys in the back. Be sure you ask for help if you have any questions.